live. It's 256 Chat with your host, Michael Fudge. Hello, everyone, and welcome to another episode of IST256 Chat. This week is Lesson 11, Web APIs, and I had trouble getting a guest this week, so I had to ask my Grandpa Joe to join us today. Grandpa Joe, say hi to my students.
Students? I don't see any students anywhere. What are you talking about?
They're virtual, Grandpa Joe.
Virtual? What are you talking about virtual? In my day, we did everything in real life. We got together like people. And we loved it. We were grateful for it. Gosh darn it. And another thing, we didn't have any of these fancy web APIs that tell us about the weather, or when stores are open, or what they had in them. If we wanted to know that stuff, we went outside like this. We all know what's the weather like. And we went to the store, dadgummit. We learned from the store. We went in there and saw what they had. And we were disappointed when they didn't have what we wanted. And we loved it.
That was great insight, Grandpa Joe. Maybe you can talk a bit about your knowledge of Python.
Python? Why would I touch a Python? Those things are dangerous.
Oh, yikes. Let's just get on with the lesson. Hello, everybody, and welcome. It's Lesson 11, Web Services and APIs. Once again, this is not out of the Zybook. It's my own authored custom reading, which you can find here at this URL. You should definitely try to review it before you do the lecture. It'll make things a lot easier to swallow. Also, if you have questions, you can ask them on Teams, which is the link is provided right here. Obviously, there won't be any live participation because this is a pre-recorded lecture. Okay, let's get started. This one's going to be a little longer than normal, but I think you'll find it's going to be really valuable. I'm going to try to put a table of contents in for the YouTube video so that you can skip around to the parts. I'm going to show you lots of different APIs today, and I'm going to code them all up myself, so it's going to take a little bit of time. But I think that works the best. I get to explain it. So we're going to dive into a lot of web APIs, do a lot of examples, and of course we'll have an end-to-end example, and all this code will be available to you. It's going to be in the class examples folder like it always is in Jupyter Hub, so you'll be able to look at it and review it. I think you'll find that some of the stuff that we go over today is going to be really helpful as you start to think and plan how you're going to do your project in the course. So this is going to be really useful for your project. So let's start out, as we always do, with our connect activity. A common two-step verification process used by APIs, as discussed in the reading, is which one of these? OAuth2, multi-factor, API key in the header, or JSON format? As we saw from last week, JSON format is an output from an API call, so it's definitely not D, but maybe A, B, or C? I'll give you a minute to think about it. Pause the video. So the answer is A, OAuth2. OAuth2, specifically with the client credentials flow, as we will demonstrate today, is a very common process used by APIs to first authenticate to the API, and then you get back a token, a bearer token, and then that bearer token is used, it's like your passport to then call the API. So it's usually a two-step process. All right, so what's the big deal with APIs? We saw last week how to call the web with the Python request module, and you can probably see a lot of utility in that. But the real interesting facet of why we talk about APIs here in this course is fundamentally they're changing how the internet works, and the internet is moving from user consumption to device consumption. User consumption is you go to Google and you type in, hey, when is George Washington's birthday? And then you get information back out, and then you figure out where the valid information is. And the web is now evolving to device consumption, where we ask our phones, or we ask Alexa, for example, these smart devices, these questions, and then these smart devices go out on the internet, search for what we want, and then give us back the information in a conversational tone. And this is moving from the internet of people to the internet of things. And this transition has been happening for a very long time now, and it's becoming mainstream. And the bones, the backbone of how this works are web APIs, because web APIs are consumable by machines through code. So very different than us going to Google and typing something in here, right? And then this is consumed by a person, like, what is the weather today? And then it gives us back some data that we can look at, and we have to read it, versus us, asking a device, okay, Google, what is the weather today?
It will be cloudy, with a forecasted high of 55 and a low of 42. Right now it's 42 and cloudy.
Okay, there you go. So I can ask my phone. I don't know how well that came over, but my phone just told me the forecast as opposed to me searching for it myself. So that's what we mean by we're evolving to an Internet of Things. And making that happen is an API, because you don't want to have to write code to sort of scrape the output of a web search. You want to just be able to get the data directly. That makes more sense. So device consumption requires a web API. I just said that, and I guess I made the slide, so it makes sense. So API is an application program interface. It's an essential, in essence, it's a formal definition of functions on the web that are exposed as a service. And most web APIs work over, all web APIs work over HTTP. That's the protocol of them. You can call functions with the HTTP protocol. You'll get back a response that is usually in text, and that text is in a format. Usually the format is in JSON or XML format. But what we want to focus on here is JSON, because JSON, as we saw last week, can be easily deserialized into a Python object that we can then traverse quite simply in Python. And we saw examples with OpenStreetMaps and dark sky weather to build a mashup where we can get the weather in any location on the globe just by typing it in. So what does it take if you have some great idea, and a lot of these apps that run on our phone, if it's not a game and it's doing something informational, it's using a web API. So you might be wondering, where can I get access to that API? Well, basically, it starts with a little bit of research. Usually I will go to a search engine like Google, and I will put in, whatever it is I'm looking for, foreign exchange rate API. And then you see what comes up. Then from there, you might read on, you might pick one of these APIs and then see if there's any documentation that tells you how to use it. Most of the documentation is going to be how to do it with the HTTP protocol. You'll see GET. Remember, GET is an HTTP verb. So I'm going to use the GET method at this URL. All right. And that basically explains how to use the API. Now, there could be code examples in Python or in JavaScript or, in whatever your favorite programming language is. But I encourage you to learn how to read through the calling the API directly through the HTTP protocol and then translating that into the language that you know. It's going to make you a far better consumer of APIs in the long run than the alternative, which is just trying to follow along with some existing Python code. Then you start hacking away in Python using what you know from Python requests. So here's an example of me importing requests, and then there's my URL, and then I'm using a get because that's what the direction said, was to use the get method, and then the response I get back is in JSON, and there we go. Now I don't have a valid access key in this particular example, and that's why I got this message back. But if I were to switch this to use my valid access key, let me go find it. There, I changed my access key and then re-executed the code, and you can see that the response worked, and then it converts from euro to any one of these currencies. So if we look down here, we might find US dollars in here. We go way down to the bottom. USD. So 1 euro is $1.08 in US dollars. Okay. So that's basically calling APIs. So APIs are really awesome. The only limitation here is what you can dream up, because odds are there's probably an API for it. If you look at some behavior that you're already using on your phone, there's a good chance that there's an API for that. So let's leverage the power of the internet. If you can use it on a web page or mobile phone, there's probably an API. Not all the APIs are free, and not all the APIs are available. So that's something that you need to sort of research. You're looking for public APIs, APIs that a consumer can use. And some of these public APIs require you to register so that they can limit your access. If you saw in the previous example with this Fixer API, I had to put in a key, an access key. That access key tracks my use of the API over time so that they can rate limit / throttle me. If I went to a website and got to read the exchange rates of various currencies, they can throw ads at me and things like that and make money and recapture some of the cost of running that service through ads. But with a web API, there is no way to recapture that cost other than to charge for the service. And so therefore, a lot of these services will limit your access to them so that they can, sort of keep the, keep the volume down and then keep their costs down in turn. So there's lots of places to get APIs, but there's also things called API registries, which are like a repository of common or public APIs that you can search through. So rather than just going to Google and looking for an API, you can go to one of these 3 sites, and they'll list out a bunch of APIs that they've already vetted and know work, and you'll be able to sort of use those. So it's also another good place to start is at one of these registries, rather than just kind of plunking around in a search engine trying to find your API. So some very popular sources of APIs are the big cloud providers like Amazon, Google, Microsoft Azure, IBM. They have some great APIs to do things, do cognitive type tasks like do text summarization, find keywords or key phrases in text, do sentiment analysis. They also do mapping. There's location-based searches. There's business searches, so you can search for a business and then get an API that returns when they're open, their store hours when they're open. You can use maps, an API, and get turn-by-turn directions from one place to another. These are all things that you probably use every day, but didn't realize that they're available as an API that you can then use. So where this ends up being really kind of neat is when you combine these together. Like you might make a project where you ask the user where they would like to go and where they are, and then you ask them for another destination, and then you provide turn-by-turn directions to both of those destinations, and then maybe suggest places where they can park by using yet another API that looks for maybe public garages or on-street parking or something like that. So that's where most of the students do things for their projects, is they find something that interests them, and then they try to figure out how they can sort of bang it together, if you will, from several of these APIs. And if you can dream it, there's probably an API out there already. Okay, let's do a quick check yourself. So a good source of web APIs are registries, cloud providers, services that you know have a mobile app, or all of the above. What do you think? A, B, C, or D? I'll give you a second to answer it. Well, as you can imagine, it's all of the above, right? Registries are a great place to look for APIs because they've been vetted and they're going to be popular APIs. The cloud providers, your big cloud providers like your Googles and your Amazons, they're going to have a lot of great APIs that you can use that do a variety of different things, like from object recognition in images to text to speech to text, you name it, they're all there. If you have a mobile app and you like the behavior in that mobile app, you might want to go to that service. You know, if you like Spotify, for example, you might want to go to Spotify and say, hey, do they have an API that I can use? And this is generally how you find APIs. These are 3 of the common ways that I have in the past found APIs anyway. There's no magic bullet to doing API research. It is research, and you're going to do research. You're going to have to do research. Don't ask us to help you find APIs. Don't ask us to learn your API. This is the big learning outcome from the course, is can you figure something out independently and get it working? You're going to write a lot of throwaway code. You're going to write code just to figure out how to use the API, and then when you get the API working, you might decide that this isn't the right API for you, or this doesn't do what you want. You're going to hit a lot of dead ends. You're going to get frustrated, but this is how it works. This is the nature of all programming, and it's a very good lesson in how to become an independent programmer, is to work with these APIs, be able to read. You do a lot of reading, a lot of just sort of figuring it out, and going from there. You know, far too many students do not spend enough time really discovering their API. You'll spend an hour with it, and then boom, you're in one of our offices asking for help. And a lot of times we'll be like, well, how long did you spend on this? And, you know, sometimes we'll say, oh, I spent hours on end. It's like, well, if you spent that much time, you would have definitely figured it out by then. So it just takes time. And you just need to be patient with yourself and patient with the process. And most importantly is, if you encounter a roadblock, try to articulate what it is you don't understand about the process. That's always worth asking. But coming into our office and saying, I don't know how to use my API, that's not helpful. We want to know why you can't use the API, or what it is you don't understand about what it's doing. Your question needs to be much more directed and in depth. Because again, we can't possibly learn everybody's API, but we can offer advice. And one of the things I'm going to do today through my demos is give you a lot of different common ways that APIs are invoked. Okay. So now we're on to the Watch Me code, and this Watch Me code is going to be very long. It's going to be broken up into pieces. I'm going to try to, when I roll this video into YouTube, put each of these examples in the table of contents so you can jump around if you want. But what we're going to do is we're going to look at a lot of different ways to call APIs through common techniques. Query string header, using HTTP post, API keys, and then finally we'll conclude with an example that does an OAuth client credentials flow. Okay, so this particular in-class example, I left a lot of narrative in here. So I'm in the in-class example, and I'm not going to read all this stuff to you, but you certainly can go back and read these. And with each of these, rather than me just showing you a bunch of code, I decided to take a little bit of time and write up what it is I'm doing and why, and what kind of example it demonstrates. That way, when you go back, the code example is a little more useful than what I gave you originally. Okay, let's start out with which is probably the easiest of API calls. That is a URL that just returns back some delicious JSON for us to consume. Okay, there's no authentication. There's nothing on the query string. There's just request and response. Okay, so this example here uses data from the USGS, where it shows you earthquakes. And this is a really simple API. Most APIs are not free like this. Most APIs are not this simple, because a lot of the government APIs are, because the government, is subsidized by us, the taxpayer, and therefore they release the information for free. So let's call this API. So I'm going to just get it, and then I'm going to do quakes is response JSON. Let's deserialize it into a Python object. Then let's just do quakes. See what we get. Whoops. Oh, I grabbed the wrong URL. Yeah. All right. Okay, so I want this one here. There we go. So these are the earthquakes in the last hour. I grabbed the wrong URL. This is the documentation page. That's the actual page that gets me the data. Okay, there we go. And so now I need to go through these quakes. And so if I look, this is no longer API call. This is how do I deal with a Python object, right? If I look through this Python object, I got a key called type. It's got a feature collection. I got a key called metadata. It's got another dictionary in here. And then I have a key called features, and that has a list. And in there is each of the earthquakes. So let's do it with a for loop. So for quake in quakes And then I want to grab the features key, because that's the key that has my list of earthquakes in it. And then I want to print, let's see here, from features, let's print the place, and let's just print the title. That's good enough, because the title has the magnitude in it and the place. So let's just print quake title. And then these are the quakes in the last hour. Whoops, I messed something up. Let me fix that. Let me take this back out again. And put in quakes again. I messed a key up here, so let's see. Properties, type, feature, properties. Oh, it's under properties. Okay. So it's quake properties title. Whoopsie. Okay. See, it's type, feature, properties, and then in there there's a key called title. It's easy to do that. So what happens is if you get a key error like you saw, then you know you did something wrong when you're grokking your Python object. So this should give me what I want. It's title, not titles. Another key error. There. So there's all the earthquakes in the last hour. What I love about this example is I run it tomorrow, I get different earthquakes. Or I run it an hour later, I get different earthquakes. Okay, let's kick it up a notch and search the iTunes API, which the URL for this I didn't include in here is iTunes Apple com search. All right, so if I go here, I get a text file back, okay? And there's nothing in the results of the text file, right? It's a simple API. So I'm going to call this API. It uses a get. So let's do this. URL is all right, and then let's say response as request get. I'm going to zoom this in just a little bit. And we're going to get that URL. And then let's just do response JSON. And we get back no results because we didn't search for anything. So the way that the iTunes API works is you need to put a search term on the query string. Now you could do this manually like this. But that's not a good way to do it. We want to use what Python gives us and what requests gives us. So we're going to do this. We're going to say parameters, and we're going to make a dictionary, and we're going to have a search term. And let's search for Bruce Springsteen. All right, and now we're going to call the URL, and we're going to pass in and maybe I'll want to call this query string. So then the named argument is params and the value is query string. And then whenever I use this, I like to print the response URL so I can see what gets generated that actually gets sent to iTunes. And then let's take a look at the JSON result. So I have the response URL is that. That's the equivalent of what I would click on, and I get this text file back, and there's the data. And then likewise, here is the results. And so I can enumerate these results too, right? So if I look through here, there's a key result count. It says 50, and it says results, and that's a list. So I'm going to for loop over that. And where's the title of, let's see, collection name, track name. There it is, track name. So I'm going to grab that track name. Let's print out all these. Let's print out the artist name and the track name and the collection name. We'll print out all three of these keys here. So let's do this. Tunes response JSON for tune in tunes results. See, it's just a matter of knowing where the collection is inside the results. So the results is a dictionary, curly brace. This key results has a list. So when it's a list, I know I can for loop over it because it's a finite number of things in the output. So I can use a for loop, not a while loop. So tune is just one of these babies. So let's print, and we'll use our famous F string here. And we're going to print artist name. So it's going to be tune artist name. Tune. This is the most arduous part of the demo, is watching your professor who can't type. Talking and typing is really hard. Hopefully I didn't screw up one of those keys, but I think I got them. There we go. Bruce Springsteen, born in the USA, I'm on fire. Bruce Springsteen, born in the USA, dancing in the dark. Okay, these are all these Bruce Springsteen ones. And I got a key error here. So at one point, there is a tune and it doesn't have a collection name. So this begs the question is, how do you deal with issues like this? Well, you should use the soft get approach that we talked about before. Rather than hard getting this, you should soft get it and then give it a default. So I'm going to rewrite it properly. I would do something like this. I'd say artist. And then rather than do this, because this might fail, right? I say tune get artist name. Otherwise, what would we say if there was no artist, right? What would be the default if this is null or empty? I want to say, because I searched for Bruce Springsteen, I could say Bruce Springsteen, but I'm going to not overwrite iTunes. I'm just going to say unknown artist. All right. And then we're going to say collection tune get collection name. And then here we're going to say unknown album. And then last but not least, I'm going to copy and paste. This one is going to be track. This is going to be track name. And this is going to be unknown song, I guess. And then down here, now I'm going to print artist. And then I'm going to print collection. And then I'm going to print track. Because I did this soft get, if it can't find something, it will just continue to chuck on. So down here, it's going to say unknown album right there. It says Colin Hanks, unknown album, all things must pass. So that comes up in the search results for whatever reason. But now I showed you how to deal with it, right? And that's the advantage of using the get method rather than doing a hard get like we did up here. The hard get with the dictionary assumes that it's available, right? The key is available. And you can't make that assumption with every single API that you call. To save a bit of time, I copied and pasted in this exchange rate example because we already did this one. But this one uses an API key and it goes on the query string. So I have this variable API key, and then I have a dictionary that I'm making. It's called access key. Why is it called access key? Because that's what Fixer.io requires. If I were to go to this website and look at the API in the docs, you'd see that it requires me to put on the URL an access key. See that? Access key right there. So that's necessary to make the query go. What I did want to show you out of this example is, let's suppose I leave that out. Let's suppose I take this out, and don't put on that, and run it. It says missing access key. You have not supplied an access key. I can't tell you how many students will come to office hours and say, I don't know why my API won't call. It keeps saying missing access key or missing API key or invalid API key. And I have to tell them, did you read the directions? Because the answer is in the error. It says you're missing an API key. You need to give it an API an API key. Well, I don't know where to give it the API key. I'm like, well, I bet you if you read this, it's going to tell you where. It's just a matter of knowing things, right? Like, you know that this is called the query string. That's why we have the week before we learn those things, so that you're more prepared for calling these APIs. End of rant. So whenever you use this approach where you're adding things to the query string, it's always useful to print out that URL so you can see what it looks like. Right? So that is actually what's being called. And if I click on it in my browser, it makes the same call in the browser, and I can see the results in the browser. So that's a little tip I wanted to show you. Very useful to do this when you're trying to figure out your API, especially when it uses gets. You can't do this with a post, because a post does not work this way. When you click on a link in a browser, it's simulating a get. It's not simulating a post. So this will not work with a post. If you want to do a post, you can't do this. Okay, let's move on to the next example. This example down here uses this phone number API, which is a really cool API. It will use a phone number and then reverse look it up to a location. And that location includes a latitude and longitude, so you can therefore plot them on a map. So let's suppose you have a bunch of customers and they have phone numbers. You can then use their phone numbers to find their locations, then plot your customer locations on a map. This would be a good example of how to use this. So let's give this a whirl here. So I'm going to make a phone number up first. So phone number is going to be my office phone, 315-443. If you're watching this on YouTube and you're not in my class, please don't call my office number. All right. Now we're going to do the URL, right? And it's going to be the URL, by the way, is not this. This Mashape is a API marketplace. So if I go here, and now it asks me to log in, I'm just going to log in with Google, and I'm just going to use my SU Google account. All right, and I can just put in my name. I always like to spell it wrong to see if they're marketing to me. Okay, let's just explore. All right, and I'm going to search for my APIs, and this one is going to be a phone number. Phone number. Okay, so I couldn't find the one I used before, which is pretty odd. But what I did want to show you is how these all work. So these are wrappers on APIs. So this is the actual API you're going to call over here, and you have to sign up for a key. And then you get a key through this service, and then the key that you use sort of wraps the API. So you're not directly calling the API, you're calling it through this Rapid API service. So you can see there's lots of languages in here. You can actually pick Python and requests. So it shows you exactly how to do it with Python requests as well. So it's actually very handy. Okay, so what I'm going to do here is I'm going to show you what I've got in code. So this is what I got from the code before. So here's going to be my query string. You put the phone number on the query string, and then here's the API key. I'm sorry, here's the API key in the headers. And then here's what I want back. I want JSON back. And then this is me calling the API and then passing in the arguments. And I guess for grins, I could print response URL so you can see what it looks like. And so that's what I'm actually calling. And then it comes back and it says that phone number is in Syracuse, New York. And then there's a latitude and there's a longitude right there. So it did geocode that phone number. Verizon, New York is the carrier. So that's an example of using one of these API marketplaces, API aggregators. Generally, you're going to get a key through the aggregator, and then you use the aggregator's key to call the actual API on their behalf. So they work a little differently. What also is nice about these aggregators is they have like a little form where you can fill it out and try out the API yourself through here. They also have, if they're not free, it'll tell you how much it costs here. So, usually there's a free plan where you can make X number of calls a month, and you probably aren't going to go over the free plan. You can see it's 100,000 a month. I don't think you're gonna max that out. Okay, so no need to put your credit card in. Let's move on to our next example. In this example, we're using an API called API Stack. And, whoop, how interesting. Maybe they changed their name. This is the beauty of APIs, is they're always changing around on you. Yeah, so now it's called Snoopy.io. So, yeah, it's great how that works, how they're constantly changing them around. The good news is the old setup that I had before still seems to work, which I find utterly hilarious. Let's see what their pricing is. So for free, you get 10,000 requests per month. This is a geocoder. So it will take an internet address. So every computer on the internet has an IP address. It will take that IP address and then tell you where on the globe that IP address is coming from. So these are what I usually call the foundational APIs. Like you might use this API to do something else. So for example, you might take the IP address of the computer and then figure out where that computer is on the map, for example, and then you need to geocode to do that. So it's one of these foundational type APIs. So let's see if we can actually use Snoopy.io. The code I have still works, and it uses their old domain name IP Stack. And let's see if we can get it to work with Snoopy.io instead. Oh, my account already exists. I've done this before, haven't I? All right, let me see if I can go recover my account. All right, I'm in. I recovered my account. I didn't want to put you through that pain. You can see that this dashboard here, if I zoom it in, has a API key, and you put that on the query string, and it also has the IP address that you want. So I'm going to take this URL here, and I'm going to copy it. And let's keep the dashboard up as I query it. Oh, it also says I didn't verify my email, so my account will not work. Let me do that. All right, after all that nonsense, I finally was able to get my key activated. So I'm going to copy and paste in my key here so that I don't have to type it, because it's... All right, so... All right, let's try to look up this IP address. I wonder where that is. And there's my API key. And so if you remember the dashboard, the format is... The URL is like this. API Snoopy.io/IP. So there's my IP. So I'm going to f-string that. And then I need to give it a query string. And on that query string, I give it the access key. And that's going to be my API key. And then I can say response, request, response, request, get. Let's make the request to the URL with my params as the query string. And for grins, we'll do a response URL. Let's print that so we can see what's happening. And then let's get a response JSON. And I got to spell response right, don't I? Right here. So there's my URL, and then this is the output. And this is in Syracuse, New York. Let's try another IP, see if it works. Try that IP. Okay, that is in Australia. Okay. So, yeah, there you go. There you have it. This is pretty neat, right? So you got another service that you can use. And, you know, it also kind of gave you an idea as to the challenges of calling these services where you have to register at the website, right, and get it, you know, put in your email and then wait to get a response back before you can use it. It takes time. Don't sign up for your API like the minute the day that you have to create your report to us for your project milestone. Get way ahead of this stuff, because some of these APIs, your access is not instantaneous, and you don't want to put in your document, oh, I'm still waiting for access to my API. We're not going to be happy if we see that. Okay, let's move on to an example here. We're almost done with our examples. This example here uses an HTTP post, because you're going to send a lot of data to the service, and that data needs to not be on the query string or in the header. It needs to be in the body of the request, so you can't use a get, you have to use a post. So if I go to textprocessing.com, you'll see that there's a bunch of demos, and one of them is sentiment analysis. And it says that you need to do a post with form encoded data, which is the default, containing the text that you want to analyze. And it will come back with the label and probability. The probability is is it positive, negative, or neutral? And the label is generally how it labels the sentiment of the text, like negative, positive, or neutral. So let's come up with some text. So I'll make some text up here, and let's just say this virus thing is really bad. Everyone I know is isolated and not happy about this situation. So, this is pretty short text, but it could just be, it could be a whole news article that you're doing sentiment on. And at one point, I will change it and try something more sophisticated, but let's just get it working first. So I would generally classify this as a negative sentiment, right? Let's see what it says. So if I go back here, I just call that is my URL. So URL is this. And now I need to put in a payload. Payload is a convention that I use when I'm sending it through the request body through a post. So the payload, if you look back here, it says text equals. So it's key value. So the key is text, and the value is what you're searching for the sentiment of. So key value I do with a dictionary in Python. So I would say payload text, and then the value is going to be my variable text. So basically this gets translated into this. And now how does that work? Post to the URL. When I post to the URL, I need to give it the data that goes in the body, and the data that goes in the body is going to be the payload. When something is form encoded, right? When it's form encoded data, what that means is that it's a set of key value pairs. It's pretty much the same as the query string, only it's sent on the body of the request rather than sent on the URL of the request. So this is a nice way to hide the data from anyone who has access to seeing the URLs. Okay, without further ado, let's see what we get back. Negative. So it says negative for the label. So maybe we can do response JSON label. That's negative. Okay, let's go grab some long text somewhere and see what it is. What's usually more polarizing than a nice Amazon review, right? So, so this one here, says, but it turned out beautiful. It took one day just putting it together. This is for some kind of greenhouse shed thing. Okay. So let's take this super positive review. Let's copy the text, right? And let's go back to here. And let's just change the text to be that super positive review. Okay, and let's see what we get. Now I have some extra quotes in here, which is throwing it off, I think. Let me just fix this so it's all on one. I gotta fix it. Looks like there's some wonkiness in here. Just find the wonkiness and fix it. All right, it's a big long message. super long. Super long. Oh, there it is, 2 inches. That throws it off. So I'm going to put a backslash in there to encode that quote. See that? So now it's all one string. Let's see what we get. This has a negative. So it just goes to show you how difficult sentiment analysis is. This person labeled it as a 5 stars. They loved it. But when you read through the text of this, a sentiment analyzer would label this as negative for whatever reason. So I guess maybe we should look at how negative it is. So yeah, it says negative 73% negative. So wow, that's quite negative. So I don't know why the sentiment analyzer does this. What you'll find out is there's other sentiment analyzers out there. You know, there's one that I was playing around with earlier called Azure Cognitive Services, which is free. And it seems to be much better at this. But you can see how you can probably make a really cool mashup for your project where maybe you have an API that reads Amazon products and reviews and then does some sentiment analysis over them. Or maybe it reads tweets and does sentiment analysis over tweets or Facebook posts or whatever. Okay, so that's using a post. So when you use a post, generally you have to feed the data, but the data is in the body. So to show you that, I'm going to do a response URL. And you'll notice that the text does not appear, if I spell response right, the text does not appear on the call, right? When you post, the data is inside the body of the post and therefore not seen by the request. So if I were to just do this, it would do a get. It does not do a post. It does a get. And that's not what we want. And so I get a 405 back, which a 400 error means you made a mistake, right? So I guess I can demonstrate this. If I change this to a get, I get an error, right? JSON decode error. And when you get a JSON decode error, it means this isn't working, right? So you need to dial it back and just look at the response. And you can see the response is a 411. And a 411 means it's 400. It means I made a mistake as the client. I'm doing something the client doesn't like. So if I do response text, usually I can read the what's in the response. So if I were to go through this, eventually I would find that I'm doing something very wrong in here, which I won't bother to look through. What I'm going to do instead is change it back to a post, which is what it should be. And then now I can use JSON. So remember that. Just don't blindly do response JSON. And if you do response JSON and you get an error for whatever reason, you know, JSON decode error, JSON decode error tells you that what you got back isn't JSON and you cannot run this command here. Therefore, what you need to do is look and see what you got back and what it is. So generally what I will do is I'll dial right back to the response object and look at it, because the response object will let me know if it's a 200 or not, and it's not even a 200. So now I know I've really borked things up and I got to fix them. Okay, let me get the example working again. Okay, good. So let's move on to the very last example, and then we'll move on and do an end-to-end example. And I told you this one was going to be a little longer, and I apologize for that, but I think that this is a very valuable exercise for the students. So in this example, I'm going to use Spotify to demonstrate how to use the OAuth 2 protocol to do a client credentials flow. And the client credential flow is the simplest of OAuth flows, where you basically take a username and password provided by the API and you send that to an endpoint on the server, which gives you back an access token, and then you use that access token to make subsequent API calls. So it's a two-step process. First thing you do is you authenticate. After you authenticate, you get back pretty much an API key that you're going to use, but you're going to use that API key in a very special way. And then from that point forward, you can then call the API. So I will demonstrate this to call the Spotify API, getting tracks for a particular album. But first things first, I will get the API token. So if I log into Spotify here with my username and password, which I've already done, I just got to figure out where I was. Let's just go, I guess, to the home page of developerspotify.com. And let's go to the console. And I'm already logged in. And here I am. And generally what you do is you hit create an app. And most of these things, whether you're using Google or Facebook, they all will work the same way. Any of these that are based on the OAuth 2 protocol are going to work the same way. They're going to ask you to register an application. Generally, what I put in here is, I'm a student in a Python class, and I'm just trying to get this to work. And basically, what you want to do here is you want to implement what's called a desktop app. So you might say, well, it's not a desktop app. It's, in Jupyter Notebook, which is a website. Yeah, I get that. But fundamentally, what you're doing is you have a client, and it's making calls to a server. So in that model, you have client, server. That's 2 tiers. So it's a desktop app. Website is different. It brokers on behalf of another person. That's not what you want. So you're generally going to pick that. If it asks you, just say you're doing this non-commercially, and then you have to check out the user agreements. But this is the same if you're going to use Spotify or Google. They all kind of have the same flow. It's just a matter of finding it. After you do this, you're going to be given a client ID and a secret. See that? And you can always regenerate that secret. But that client ID is fixed for that application that you created. You will use that client ID and secret in your code. Copy. These 2 things function as the credentials that you use to log in to Spotify. In the documentation for doing the client credential flow, it shows you that you need to do a 2-step process. You log in with your client ID and secret key, and you'll get back an access token. All right? And here's the endpoint that you log into, and you do a post. See that? You do a post. So let's implement that. So how do I do a login? That's what you might be wondering. So I'm going to do this. I'm going to say, let's call this token URL is this. And then we're going to say response is request post to that token URL. And we need to pass in the client ID and secret as the authentication, right? So we do it this way in Python requests. We say auth equals, and then we pass in the pair, client ID. And what we should get back here is my credentials. Whoops, I did not get back my credentials. I got back an error. Said I did something wrong. So I need to dial this back. Let's see. Did I at least get a 200 here? I got a 400. So I screwed something up. Okay, let me just verify my endpoint and... oh, you know what I didn't send in? The grant type. I forgot that part. I sort of skipped that. But I need to also give in the body the grant type. Set it to client credentials. I wonder if it tells me that in the error messages. Let's see what response text says. Wrong. Oops, something went wrong. Please try again. But it doesn't tell me what went wrong. Okay. So it's not very helpful. But what I need to do here is in the payload of that post, I need to give it a grant type. And I need to tell it what I'm asking for. And in this case, I'm asking for an access token, which is called client credentials. Okay, and then I need to pass into the data the payload. And then that should give me what I want. Okay, there we go. So now I have my access token. So now I could try to deserialize this. I could say token is response JSON. And then now if I do token, I get a nice Python object. So there's my access token, and it expires in 36 seconds, 3,600 seconds, which what is that? 50 minutes? Okay. And it's a bearer token, which is the common token. So now I can call the Spotify API. So I'm going to just can this. Here's some URL to some album ID that I just got from the Spotify API examples. I don't even know what this album is. It's not really relevant. I can do a search through Spotify if I want, but I'll leave that up to you if you're going to use Spotify at all or whatever. Or, there's lots of different, if I go back here, and I go to Docs, Discover, right? And then maybe I want to search, there's the URL for doing a search. I can read all about it. I'm doing a get, right? And then on the query screen, I could put the artist. See that? So maybe I will do this because I'm here, right? So I'm going to take this endpoint. Why the heck not, right? And let's go back here. And rather than just go get a user, a track, let's do a search. And then my query string, what does it need? Let's go read the docs. It needs a query and a type. So let's put in Springsteen, and then the type is artist. And you see it fills in the request over here. I don't want to manually do this. I want to do these with keys and values. Keys and values. Okay, so let's go back here and let's do some keys and values. I already forgot it. Q and type. Type artist Q Springsteen. Q. Let's go Springsteen. And type. He's an artiste. Okay. Then I also need to give it headers. And the headers that I need to give it, one header I need to give it is the authorization header. And the authorization header is always going to be this access token here. It's like this, bearer. And then right after bearer comes the access token. I'm going to fish that out this way. I'm going to say access token is token, right? Token is here, and I'll take the access token key out. Okay, so that's going to put in that bearer. And then now I have what I need to make the request. I can say response, requests, get that URL, and I need to pass in the headers and the params is my query string. You can see all of that right here. It's building the URL for you. Curl is a command line program that you can use to simulate, to actually generate, not simulate, actually produce an HTTP request. Curl-x is the method, get, and then this is the URL you're getting. And then these are the headers. So it's saying, give me back JSON, and then content type application JSON, and then authorization bearer, right? But it doesn't show you the key on here. It just won't do that. You have to put the token in here. I'm not doing that, but I guess I could. And see, there's my bearer token. See it right there? Okay. So enough is enough. Let's see if it works. Oh, the token expired. Okay. All right. Hold on. I'm doing something wrong here. I'm re-asking for the token, right? Token URL. Let's print the access token. All right. How is that access token expiring already? Let me try a different query and just see maybe I didn't give it the right grants. Because it could be something as simple as it doesn't have the right grants. Only bearer authentication is supported. All right, let me dig around a bit. I must be doing something wrong. Hold on. Okay, I got it working. I was using the wrong secret. So, yeah, that happened. Remember, I regenerated that secret and then I was using the wrong one. Okay, so now it works. So I run this. It generates my token. Then I use that same token to search for Springsteen, type artist, and then what I get back is a bunch of JSON data. And if I look through here, here's Bruce Springsteen. And then here's Alana Springsteen. And all the little Springsteens. Palm Springsteen. There's a bunch of them in here. Okay. So there you go. It works. I get back data. What I choose to do with that data is up to me. But that shows you how the two-step works. Now, if I want to make another API call, I don't need to keep asking for a new token. Okay, that token's going to be good for a while. So, I can search for something else. Like maybe what I'll do is I'll just make a loop here. While true. Do all this. I'm going to be really lazy about this. Let's just print response JSON. And then in here, we're not going to search for Springsteen. We're going to put in text. And then down here, we're going to say text input enter artist. Or quit. Right? That's fine. And then if text equals quit, we're going to break. Okay, let's try this. So let's put in Bon Jovi. Okay, and then if I look through here, I know it's a bunch of, there's Bobby Bon Jovi. Okay, so there's one. Enter another artist or quit. Now I can put in something else. I didn't reissue the token, right? This code is still using the same token as before. It's, I got the token once. Okay, so let's try this again. Let's put in Nelly. Okay, and there we go. Nelly Ruse. So there you go. And then I can type in quit. So it keeps using the API over and over again. It keeps using the same token over and over again as it calls the API. That's exactly what we wanted. All right. So there's your boatload of demos. I know that took a long time, but hopefully you'll find that very useful and helpful when you go about doing your projects. And I'll make sure you have all this code. Obviously, some of these keys and secrets won't work. You'll have to get your own for those, but I'll keep as many of them around as I can for you. Can't be having you hacking my Spotify account by any means. All right, let's bang out this end-to-end example. I think this will probably take me about 20 minutes or so, so I'm going to be a little over on time as I promised before. But what we're going to do is we're going to use the Yelp API, which the Yelp API allows you to search. If you've never used Yelp before, it is a service that lets you search for restaurants, and based on those restaurants, you can see reviews of the restaurants. So it also searches for other things, but what I want to use Yelp for is I want to search for a cuisine in a location like pizza in Syracuse. And then I want to get back these reviews, and I want to compare this review that says 3 stars, see that, 3-star review, against the text and the sentiment of the text. So if it's a 1-star review, then the sentiment should be pretty negative, right? Because that would be a match between how they rated it and how their wording says how they rated it. And this is a basic form of sentiment analysis I want to do to sort of figure out if there's a disconnect between the opinion of the rating and the words that they write in the review. Okay, so let's get started with the example. And again, I will take a battery of approaches here in this example. And mainly I'm going to use problem simplification and a bottom-up approach. So what I'll do is I'll first think through my algorithm, and then from there I will make sure I have all the components of my algorithm that I need, and those that are too complex I will write as functions. And that's basically how you take a bottom-up approach, and that's a very good way to do your project. So here's my algorithm. I'm going to prompt for a location, ergo Syracuse. Then I'm going to prompt for a cuisine, like Thai. Okay, then I'm going to search Yelp for that cuisine in that location. Don't know how to do that. We'll figure it out. Then for each restaurant in that matching search, what do I want to do? For each of those restaurants, I want to use Yelp to get the reviews for that restaurant. Then I want to, for each review in restaurant reviews, what do I want to do now? I want to get the sentiment of the text of the review, and then I want to print the reviewer name, the reviewer rating, 1 star to 5 stars or whatever it might be, and the sentiment score. That way I can visually see if the rating of 5 matches the sentiment score of positive, or the rating of 1 matches the sentiment score of negative, which it should be, right? That's basically going to be my algorithm. Now, there's bits and pieces of this that I can do pretty easily, and there's bits and pieces of this that I cannot do easily. The things that I cannot do easily, I will write as functions. That is a very good approach to take. That's the problem simplification approach. That's the bottom-up approach. The problem simplification approach is, rather than prompting for a location, I'm going to hard code those locations in to start so that I have a little bit of sanity over making my API work the way I want. Okay, so let's start there. Let's say location is going to be Syracuse, New York, and cuisine is going to be Thai. Okay, now I need to search Yelp for that cuisine in the location. Now, there's a couple ways you can do this. I'm going to take what is called the black box approach. I know I need to do this. Okay, search results is Yelp search the location and cuisine. Okay, I didn't write Yelp search yet, but I will. But I know I need to do that. Okay, I'm calling a function that doesn't even exist yet. It's not a big deal. Okay, search results is going to be some kind of collection that I can loop over, right? But I don't know how I can loop over it until I get it yet. So now I'm at the point where I have to stop. And I have to now write Yelp search. So I'm going to put a cell above here and write that function. And I'm so lazy at this point, I'm going to just copy it and do this, def Yelp search. Okay. I do not know how to do this yet. As a matter of fact, it's probably unwise for me to write it as a function right now until I know what the hell I'm writing in the first place. So I'm actually going to even comment out the function, and now I'm going to start to dig around in Yelp. Okay, so here I am. I logged into the Yelp API, and I'm at the developer's dashboard, and this says REST API. That's exactly what I want, the Yelp Fusion REST API. So I'm going to just click on that. Let's go to documentation. And there's some business. Oh, there's search. Okay. And it says, there's my search. So I can do that, right? So we'll just say URL is this. And response requests get the URL. And then let's just say response. What the heck? What happens? I get a 400 back. So it's not working because I'm probably not giving it everything I need to do a search. I didn't read through the rest of the directions. So let's go do that. So these parameters should be in the query string. Term, location, latitude, longitude, blah, 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 blah. Right? These need to be in the query string, which you set up as parameters. So I'm going to put in term and location. And the search term is going to be Thai, and the location is going to be Syracuse, New York. Okay? And we're going to hard code those in. Term, Thai, location there. And then no point in writing this as a function until I know my code works. So let's get the code working. Still getting a 400. I betcha I cannot call this API without some kind of key. So maybe I should go to introduction and read there. Yelp Fusion API uses a private key authentication. Oh, so I can't do this without a key. Okay, all right, let's take a look here. What's the key say? Let's go to authentication guide. Okay, it says create an app on the developer site. Okay, which I already did. And then here's my API key. Now the question is, where do I stick this API key? I don't know. No idea where I'm sticking that API key. Let's see if it tells us where to use it. My bet is that this is OAuth 2 because I see a client ID. This is OAuth 2, and this is going to be my bearer token. Is going to be my guess. But I'm looking for where it tells me that. All right, let's go back to the Fusion API. I'm digging around here to see if I can figure out where it is. It's got to be around here somewhere, right? There it is. Yep. Authorization. Header bearer API key. So there it is. Okay, so I did find it. All right. Now, see what I mean by you got to poke around? All right, so let's do this. Key. I'm going to call it the Yelp key because I might need another key. I don't know. There it is. And then I know I need to do this. Authorization, right? Where did I get this information from again? Right here. Set the authorization HTTP header value to bearer space API key. That's what I just did. Let's see if it works now. Oh, still getting a 400. All right. Let's see, did I make any knuckle-headed mistakes in here? Oh, I call the URL. I don't pass in the parameters or the header. That would be helpful. Now I get a 200, so it worked. So now I should be able to deserialize that JSON. And I can. And I can see that what I get back here is a key called businesses that has a list of the businesses. All right. So what do I want to return back? These businesses, right? So there we go. So now I can write my function. My function looks like that. I don't need these variables because they come into the function, so they can go away. And then this all moves over. And what do I send back? This. Okay, let's give it a try. That returned an empty. I wonder if it needs to be capitalized. Oh, duh. Location. Boy, what a knucklehead. Location goes first, then cuisine goes second. See, fall asleep for 1 minute on the job. There we go. Okay, so now this is done. Yelp search is done. And now I can come down here and loop over the search results. I could say for restaurant in search results. Okay, now what am I going to do next? What did my algorithm say to do next? Use Yelp to get the reviews. Well, maybe the reviews are already in here. I don't know. Let's see. The rating is in here. See the rating of 4.5? But I do not see the reviews. The name of the restaurant is in there. Okay, and there's actually an image URL. Let's have some fun with these name and image URL. What I'm going to do up here is I'm going to do import, because, you know, I want you to jazz your projects up, right? So I'm going to import from here, from ipython.display, import display HTML and image. Watch what I'm going to do here. For REST in search result, let's display using HTML. Let's use an F string, and let's put a header tag. Okay, this is HTML markup. And then in between the header tags, I'm going to put in REST name. Let's see what this does. There's all my restaurant names. Now, is it a little too much for you to swallow this? Let me break it up for you. Restaurant name is this. And then let's put restaurant name in here. That's a little easier probably to stomach. Okay, now we got a restaurant name. Let's grab this picture of the restaurant, which is right here, this URL, image URL. See that? So let's do this. Let's display under that. Let's display an image of REST image URL. Oh man, look at that. I love Thai, Thai flavor. Now these images are a little big. Okay, so you can control the size of them by shrinking them down a whisker. Let's change the width. It'll scale accordingly, right? So if I read how to use image, it would tell me how to do this, but I already know how to do this. Width, let's do the width of 200, and it'll make them a little smaller, 200 pixels. That should be good. Yeah. So there's I love Thai, yummy. Thai flavor, yummy. Maybe I want to include a description. Is there a description in here? I don't see any kind of description. So I guess I'll have to just live with this. Okay, so that's good. Now let's, that was a little tangent, but let's keep going. Tangents are good. So the reviews aren't in there. So now I need to figure out how to get the reviews for the restaurant. So again, let's do the black box approach. I'm going to do something like this. I want to say reviews is Yelp get reviews. Now, what do I need to give it to get the reviews? I don't know. So I need to go find this out from Yelp. Let's do that. And then, of course, I'm going to need another cell up here to write my function. All right. Let me take this output and collapse it. There we go. Okay. So I'm going to do something like def Yelp reviews. We'll leave the word get out of it. And I don't know. I'm going to have to give it something. I don't know what. Okay. And then it's going to return back a list of reviews. I just don't know what I'm doing yet. So let's go back to the Yelp. And let's see what's under business. Business endpoints. Business. That's not there. Is there some reviews in here? Do you see? Oh, reviews. There it is. Oh, there it is. Okay, I can do that. Taking that. Back over here. URL is this. Going to be an F string. Where's ID? ID is some Yelp ID, apparently. Let's go see what we got in the output here. Here's the ID for Thai Love NY Syracuse. See that? I'm going to take that, baby. Again, when you're starting out, just hard code it. Okay. So response requests get the URL. I'm still gonna have to give it the header from before, and I'm gonna have to generate this header again because every single one of these requests needs to be authenticated. Do I need any query string? I don't know. I didn't look. I can put in a locale, which gives me it back in English or French or whatever language I want. But I'm going to do U.S. English to start. Okay. Let's see what we get back here. Let's do a response. I got a 200. It worked. So let's see what the JSON looks like. Text. Guessed red curry dang chicken is my favorite. I also like the sophisticated jazz background music. Okay, so that's the review text. It's not all of it. You see there's an ellipsis here, and that's because the way Yelp works is unless you pay for the API, you don't get all the reviews back, and you don't get all the text from the reviews back. Okay, all right. So let's just get these reviews out. So it's under the key reviews. So I want to say reviews. Okay, and there's my list of reviews. Okay, and you notice it only gives you 5, but whatever. This is fine for the example. So now I need to turn this into a function. So what goes in here is the Yelp ID, which I'm just going to call ID. Okay, Yelp reviews ID, and then all these go over. I don't need to pass in the ID anymore, but I need to return the reviews. Okay, then I go down here and let's try it. Yelp reviews, and let's use this for the ID. Okay. It's def, not del. Def. There. And there's my Yelp reviews. So I got Yelp search working. I got Yelp reviews working. So let's go down here. So I'm going to take the restaurant ID for review in reviews. For each review in restaurant reviews, get the sentiment of the text review, which I've already done that. Print the reviewer name and the reviewer rating. So let's just do the reviewer name and reviewer rating for now. Print. Let's see what this looked like again, this output. Rating. User name. See that? User name, Jeffrey B. User name, user key, name key. Okay, print. Let's just do it this way. User review. User name, comma, review, rating. Okay, let's see what we get. Ty Love New York, key error. Oh, rest ID like this. That's the key. Thai Love New York. Those are the 3 reviews. Bangkok Thai Restaurant. Those are the 3. Oh, it only gives you 3 reviews. Those are the 3 reviews. Thai Cuisine. Those are the 3 reviews. Okay, so this Katie gave it a 5. So if I sentiment analyze her text, it should come back as positive because you would think if someone gave it 5 stars, they like it, right? Now, granted, it's going to be tough to do because we don't have all the text, but let's just see how good it is. Again, this is just an exercise. Okay, so I got that. The last thing I need to do is I need to do this get sentiment. I've done that already up here, so I'm going to go find it. I had right here. So I'm going to make a function out of this one. Let's go down and do one more function. Def get sentiment with your text as input. Now I'm not going to use this text here. That text is no good. And then I'm going to if I run this, I might have went a little too fast on this one, but let me just do this. Get sentiment. Let's return this. And then get sentiment, you suck. And that says negative. What do I want to return back here? Do I want to return just the label? Do I want to return these numbers? For now, I'm just going to return the label. I mean, this is not really probably the best way to do this, but again, I'm already 10 minutes over. So let's just return the label. So I say, I don't want to print this anymore. I don't want to print this URL. So I say get sentiment, you suck, it says negative, and then let's say get sentiment, you are the best, and then that's positive. Okay, so that seems to be working. So now I can use get sentiment in here. So let's do that. Sentiment, get sentiment. This is calling another API, and what we're going to pass in is the review, and I don't remember what it is, so I'm going to go have to look. Review text. Review text. Review text. Okay, and then let's print the sentiment. Let's see if they match. Ty Love. Positive, positive, positive. So far, so good. Positive, positive, positive. Okay. Okay, positive, negative, negative. There's a 5-star and it's a negative review. Neutral, negative, negative. That's a 1-star review, negative. That makes sense. 4-star negative doesn't make a lot of sense. Positive, negative. So there's a little bit of a disconnect. So what I might want to do is have the review text in there. But I think one of the reasons why it's having trouble with sentiment analysis is it doesn't have all the text, right, of the review. It just has like the first N words from the text. That's just the way the API works. Okay. But it doesn't dismiss the example, which is still pretty cool, right? Because we mashed up the Yelp API with a sentiment API, and we produced a very simple program. And you can see there's really not much to this, but it's pretty powerful. The main program is 12 lines of code, and then I've got a couple of functions that I wrote. And this would, if I were to consider this a final project, I'd say that this is about a C level final project. It needs a little more to it than this. This is a little too simple. You can see that there's not really a lot of code in here. Although it takes you a while to get to this point, which should be very satisfying. So let's actually open up the floodgates here and let's input, enter a location, and then let's input, enter a cuisine. And let's run it again. Syracuse, New York, pizza. And now I get back pizza places. Cool. So how could you beef up an example like this? Maybe using a map, maybe giving directions on how to get to these places, maybe showing this and then having them select one, like toss and fire pizza, and then giving them directions on how they get to there. Those would all be great ideas. Maybe not using the reviews from Yelp, but using the reviews from Google or something. So you use Yelp to search for the product, the restaurant, and then maybe use Google to get the reviews or something like that. But adding some complexity to it. Obviously, I don't want to have to rerun this as well. It would be nice if it just ran and I could just keep doing this over and over again rather than rerunning the cell. That's another thing to think about when you're making these final projects. So let's do one more. Let's do there we go. Pretty cool. It's still calling the API and querying stuff. That's why it's taking so long. Boy, there's a lot. And you would expect that. Still going. Still going. Maybe I should have put a limit on there. Pretty cool. I like it a lot. It's fun. I like that it has the photos in there. That's cool. And you can see it's not that hard to do that. when you leverage IPython display and import the right things. Okay. So let's leave with our exit ticket. Which type of API authentication is required by the Yelp API? What did we do? Did we use OAuth2, API and query string, API key and header, or other? Okay, this is a tricky one. Pause the video if you want to answer. Technically, the Yelp API is using OAuth2 client credentials, except the first step where you take the secret and the key to generate the bearer token, that has been done for you in the Yelp API itself. It has already generated that bearer token for me. So it sort of simplifies the process. I don't have to do that myself. It handles that for me. So technically it still is OAuth2. A lot of these, anytime you see the word bearer in there, it's using OAuth2. Okay, it's just how is it using OAuth2? Okay, thank you for being so patient with me. I hope you found this valuable. Keep well, and we'll see you again next week. Bye now.